Hi students, today I am going to explain bond length. The topic comes under in this chemical bonding chapter. Here, bond length is the average distance between the two nuclei of two bonded vibrating atoms in a molecule. Look here, the average distance between the two nuclei of two bonded vibrating atoms. Here I am going to take atom A and atom B. I mentioned atom A whose nuclei is Ra and atom B whose nuclei is Rb. We are going to measure the distance between this atom A nuclei and atom B nuclei. This distance is called as the measuring of this nuclei between two bonded atoms is called as a bond length. Okay, here I am giving one more example. Here I am going to take BCl3 molecule. The distance between this boron and chloride, the bond length is about 0.174 angstrom or nanometer. This is all about bond length. Next, the unit of bond length is angstrom or a nanometer. Here angstrom, the value of angstrom is 10 to the power of minus 10 and nanometer, its value is 10 to the power of minus 9 meter. Next, we know that the bond length is nothing but the average distance between two nuclei of two bonded atoms or two bonded vibrating atoms in a molecule. What are the factors affecting this bond length is, the first one is bond multiplicity. Bond multiplicity is nothing but bond order. And second factor affecting is size of the atom. First we move on to bond multiplicity. We know that the bond order of triple bond is higher when compared to bond order of single bond. Here bond length is independent on bond order. That means bond length is inversely proportional to bond order. That means higher the bond order, lower will be the bond length, or lower the bond order, higher will be the bond length. In this case, the bond order increases, bond length decreases. If bond order decreases, the bond length increases. As the case of triple bonds having a higher bond order when compared to a double bond. So these double bonds are comparably least bond order when compared to triple bond and having a highest bond order when compared to this single bond. So single bonds having a lowest bond order. Vice versa, these single bonds having a higher bond length when compared to a triple bond. So triple bonds having a lowest bond length. This is about first factor, that is bond multiplicity. We call it as here triple bond having a least bond length when compared to a double bond. These double bond contains least bond length when compared to this single bond. So this single bonds having a higher bond length or a highest bond length or highest bond multiplicities. Next, second factor is size of the atom. Look here, bond length is inversely proportional to bond order or bond multiplicity, but in the case of size of the atom, this bond length is directly proportional to size of the atom. This means the bond length increases with the increasing in the size of the atom. As we know, in our periodic table, when we move on to from left to right, the bond length is size of the atom is decreases. When we move top to bottom, the size of the atom is increases. Right? So size of the atom increases, bond length also increases. Next point is, the stronger the force of attraction between the bonding atom, the smaller the bond length. The stronger the force of attraction between bonding atom. Here in the case of triple bonds, in this triple bond there is a strongest force of attraction between bonding atom. So in this case the bond length is smaller. But in the case of single bond, there is a least strongest force of attraction between these single bond atoms. So it having a highest bond length. However, the bigger the size of an atom, the longer will be the bond length. Bigger the size of an atom, the longer will be the bond length. Example, molecule. Here I am going to take BCl3 molecule. In this BCl bond, the bond length is about approximately 0.174 angstrom. And B2H6 molecule, here the bond BH bond, the bond length is 0.132. Next one is significance of bond length. Look here, when the bond length becomes short, a strong and stable molecules are formed. When the bond length becomes short means, in the case of triple bond, the bond length is short, right? In this triple bond, these triple bonds are strong and stable one. But in the case of single bond, the bond length is highest in this case single bond, but here in this single bonds are weak and unstable molecule. This single bond forms weak and unstable molecule. That means we can break easily these single bond atoms. But in the case of triple bond, it requires more melting, boiling point and to break these triple bonds. And second point, as bond length becomes short, the melting point and boiling point and density of the compound increases. The bond length becomes short means, in the case of triple bonds, the melting point, boiling point and density of the compound increases. Yeah, it should be happens. Why? Because triple bonds are strong and stable one. So when we have to break this triple bond means it requires more melting and boiling point, right? So in this case, as the bond length becomes short, the melting point and boiling point and the density of the compound increases. These two are the significance of bond length. This is all about bond length. And next one is bond angle.